All right, welcome everybody. This is section 1.3 of the homework. I don't even know what it's about, so let's take a look. I should be able to get to the next page. There we go. So this right here, this problem right here, by the way, this should be a small f. When we deal with a function, we use small letters. F doesn't necessarily mean function. It just means it's the function f. So that's f of x. X squared plus 7. And it says find this. Now, you may not know this, but this is the basic part of calculus. Knowing this formula right here is calculus. And you're actually going to have to do this on a test, and you'll see that this is taking the derivative. So what we're going to do, I think I'll talk about more of that in 2.1, the difference between calculus and algebra and not calculus. But we did this in algebra. This is an algebra problem. So what this says is, first we want you to find this function. So let's find this function right here. I want to find function x plus the change of x. That triangle symbol is another way of saying the change of x. So what we're going to do is x squared plus 7. What we're doing is plugging this into x, right? F of x, whatever's here goes into the x spot of the function. This is x squared plus 7. So I'm going to put a parentheses, square plus 7, and I'm putting my x plus change of x in here. And we're going to do the algebra. X plus change of x. In order to do that math, you have to write it twice. Oh, I don't want to do it in red. You have to write it twice and multiply it and FOIL it. X plus change of x squared is x plus change of x times x plus change of x. And then you FOIL it. X times x is x squared. X times change of x is x times change of x. Change of x times x is x change of x. And change of x times change of x is change of x squared. We're going to combine like terms. These two combine. And we get x squared plus 2x change of x's plus change of x squared plus 7. So that's what we get in this when we plug x plus change of x into the equation. So I'm going to write it over here. I'm going to write it in blue. That's our first part. So this is what we got for that first part of the function, x squared plus 2x change of x plus x squared plus 7. Now, and I'm going to put it in parentheses. And then we have a subtraction symbol. And I'm going to put subtraction. And now we want to find f of x. Can somebody tell me what f of x equals?
X squared plus 7.
Yes! I just want to make sure everybody understands. That is f of x. So I'm going to put over here in black x squared plus 7. And below, we get change of x. So we put that in here. We put this in here. And this is the bottom. Now we just combine like terms. If my pen will let me work. Do you see? Oh, let me just distribute this. This is a negative sign. You had to distribute it. This becomes, I'm going to write it right below here, negative x squared minus 7. Negative times x squared is negative x squared. Negative times a positive 7, negative x. So x squared minus x squared cancels out and turns into 0. A positive 7 and a negative 7 cancels out and it turns into 0. What we're left over with is 2x plus change of x plus x squared all over change of x. I feel like I'm missing something here.
It's I think it's 2x change of x instead of the 2x plus.
Yeah, I see that. Yeah. Let me erase that. I'm getting messy is what was happening. 2x change of x plus x squared is left over. And I think that's it. That is the answer to this problem. And if I look at this, I mean, another way of, I mean, this is the answer. That's all we had to do in algebra. Another way of looking at this, you can put 2x change of x over change of x plus x squared over change of x. So you can put this change of x here and this over here and make it look like this. Then eventually this one will cancel out and you're left with 2x plus x squared over change of x. So that's not a multiply sign, that's just a dot. So that's what you end up with. So all this is algebra, plugging in and doing the math. It looks like everything went. Oh, wait, see, I did miss something. I thought there is something wrong here. Sorry about it being so messy. I'm going to erase the bottom. I'm going to erase this because I know there's something at the end we have to do. Look up here. I'm going to put it in red. We have this, and I wrote it wrong. There's a change of x right here, okay? So that's important. Those two canceled out. These two canceled out. And so this is what we're left with. We are left with 2x change of x plus change of x squared all over the change of x. There, that makes more sense. I didn't bring the change of x over when I did this problem. I had to put the change of x there. It's change of x squared. Now, if you look at the top, I'm going to factor out a change of x. And I'm left with 2x plus change of x. Because it's an x squared, I took one of the change of x's out here and here. All over change of x. These cancel. And then this is the answer then. This is the final answer. Oh, waiter, Peter's in the waiting room. Change of. So our final answer is 2x. Do you see? These canceled. I'm sorry, I'm running out of room here. I see you, Peter. Give me a second. When these cancel, we're just left with 2x plus change of x, and that is our answer. And that has meaning in calculus. Right now, in this section 1.3, all we want you to do is the algebra. We did this in college algebra. We did this exact problem in college algebra, but it has meaning in calculus, okay? So I'm going to hit pause for my recording because Peter is here. You guys don't know who he is. Pause recording. All right, so the second question in 1.3 is just find the domain. Once again, very basic algebra, but you have to know domain in calculus, so they come up with this. The domain for square root functions, this first one, let's look at this first one. The domain for square root functions remember, inside of a square root, it must be positive. You must have not a positive number inside, but once you do all the math inside, you need to have a positive number so you can take the square root. So the way that you do domain is the inside has to be greater than or equal to 0. Right? You can take the square root of 0. You can take the square root of any positive number, but you can't take the square root of a negative number. So remember, domain, just in case we're having problems with what domain stands for. Anybody give me a definition of domain? Anybody know something very basic definition of domain?
The value of x.
Yeah, basically domain stands for what can x equal and I get a valid answer. You know, if I put 0 in here, 0 minus 1 is -1. If I put square root of -1 in my calculator, it says error. So 0 is not part of the domain because it doesn't give me a valid answer. So, you know, I'm looking for all the x's that give me a valid answer. A domain, what can x equal? And I get a valid answer. The way you do that for square root functions is you say that inside has to be 0 or positive. X minus 1 has to be greater than or equal to 0. And then solve for x by getting 1 to the other side. And that's the domain. X has to be greater than or equal to 1. If you put 0.9 in here, that's less than 1. 0.9 minus 1 is -0.1, and I get an error on my calculator. So another way of writing this, once again, you can equal 1, and it goes all the way to infinity. This is called set notation, right? Interval notation, sorry. Interval notation. The way to do that is graph it. Here's 0, here's 1. X is greater than or equal to 1. The brackets mean equals, greater than or equal to, or less than or equal to. Parentheses mean there's no equal sign. So that's the graph answer. This is the interval notation answer. And we have one more answer. It looks like this. And we call that set builder. Set builder answer. So there's one answer, there's one answer, and there's the graph answer. There are 3 answers here, just written in different ways. Tell me what x can equal. What's the domain of x? Okay, so let's look at the domain for tangent of x. My camera's all messed up, but I'm still going to do it. I want to look at the domain on my calculator. So on my calculator, let's make this a little bit bigger. I think I can do this. Can I get to my camera here? Pull this down a little bit. Go to my other camera. It's going to be a little messy. There we go. So on my calculator, oh no, I have reverse. Oh, I'm telling you, I'm just having a bad day with calculators today. I mean, with cameras today. My calculator is reversed. Give me a second. Let's see if I can unreverse it. Yes, mirror there. Unmirror it. Okay, we're back in business. Okay. All right, so here's my calculator. I promise you, hopefully next week it'll be a little bit better, so I get my I have this Evo camera and it's not working. they just gave me a new one. My last one broke, so then they give me a broken one. So I'm going to put in the function tangent of x. Y equals, there we go. So if you've never used a TI-84, hopefully most of you have, y equals, and I'm going to type in the tangent of x. There's the x button, and then close that parentheses. My window is normally set at -10, 10, 1, -10, 10, 1, where this is when the x-axis from -10 to 10, the y-axis is from -10 to 10. And when I graph that, I have the function tangent of x. This is what it looks like. So can somebody tell me, can you tell by this what the domain is? It's really kind of hard, but can you tell me what the domain is by looking at this? At x equals 0, I get a part of graph. At x equals 1, I have a graph, I'm on the graph. At x equals -1, I can find a spot on the graph that has at x equals -1. Is there any x value that I can't touch the graph? Does anybody know of any x value for tangent of x that I cannot touch the graph?
No.
What if I can come up with one? Okay, so there is one. Look right here. Look, this graph goes up. There's something right here that you can't see. Can somebody tell me what's right here that you cannot see? What do you call this invisible line that you cannot see?
An asymptote.
It's an asymptote. And an asymptote is a part of the graph where is a part of the entire graph that your actual graph cannot cross. So this line, do you see there's an invisible dotted line right here. And this graph gets really close to it, but it never crosses it. So that's not part of the domain. Whatever this value is right here is not part of the domain. So it's really important that we know this. This is from pre-cal, by the way. So let's take a look. I'm going to do something else. Give me a second. So one of the papers that I asked you to print out, or I think that's during week 2, but I would print them out now. Is this it? Oh, this is not even the one I wanted, I don't think.
Sorry, can you make the camera bigger so we can see a little bit better?
Yeah, just a second. Hang on. Are you using a cell phone? I thought it was pretty big already.
Well, for me, the graphs and the slides is what you're looking, and you have a little picture.
Okay, let's see if I can make this. It's actually not. There we go. That's max right there, I think. Yeah, that's the maximum I can do it. And once I have that other camera set up, it'll be better. Let me look through. This is not the paper I want. There's another one that we have to print out. Okay, so this is one of them. This is really hard to read, but if we go to print it out, this is the one that says trig on it. This is the one that says trig on it, and I'm looking at this piece of paper. It's really dark. If we look down, if we look down, give me a second. Down here, I'm on the trig, one of the trig handouts, the part that has the unit circle on it. I'm looking down in the lower right-hand corner. It talks about trig inverse functions, and it goes from negative pi over 2 to pi over 2. It talks about that's the domain for inverse tangent functions. The reason why that's the domain is because pi over 2 is an asymptote. So pi over 2 is an asymptote on here. In other words, if you look, what pi is 3.14. 3.14 divided by 2 is like 1.6. Do you see right here at 1.6, there's an asymptote that goes up and down. So pi over 2 is not in the domain for tangent of x. So pi over 2 is not in the domain. And then if you add a pi to that, 3 pi over 2 is not in the domain. Add a pi over that, 5 pi over 2 is not in the domain. Add a pi to that, 7 pi over 2 is not in the domain. Same way with negative pi over 2 is not in the domain. Negative 3 pi over 2, negative 5 pi over 2. Those are where the asymptotes are. So the domain of this function, I'm going to get out of this camera now, this particular camera. The domain of this function, the domain of tangent of x, is x can equal all real numbers except pi over 2. X cannot equal pi over 2, or a multiple of pi over 2 times a number, and there's got to be a way of just there's probably an easier way of writing this. Pi over 2 plus times n. I mean, where n equals 1, 2, 3, or n equals a integer. Let's put it that way. N equals an integer, because it could be negative or positive. So if n is 1, then you got pi over 2. If n is 2, no, n can't be 2. It's got to be n plus. There we go. N pi over 2, where n is 0. 0 is pi over 2 if you put a... Oh, I'm sorry. Let's see. Trying to write it. I know your book's going to have a... You'll see the way the book writes it down. Pi over 2 plus n pi. So starting with n equals any integer, where n, if n is 0, then you have pi over 2. If n is 1, then you have 3 pi over 2. That's an asymptote. Pi over 2, 3 pi over 2. If n is 2, if you put a 2 here, 2 pi plus a half is 5 pi over 2. So this is one way of writing it. You'll see the book has a lot of different ways of writing this. In the show your work, that's all I would need, something like this. But n can be, or x can be any real number except a multiple of pi over 2. Except a multiple of pi over 2. So that's the domain for tangent of x. All right, yeah, I'm definitely taking a long time on this section. Okay, let's see if I can get to the next slide. Is that the last slide? That can't be the last slide. Why is that? Let me, oh, there we go. All right, and transformations and algebra. Hopefully this is really basic for everybody. I'm just gonna do one graph transformations and look at it. I'm gonna do x squared on my calculator. Oh Lord, back on the calculator. Try to get it. This is as large as I can get it here. So when I go to my calculator again, I promise the other camera works so much better when I have it working. The other one just broke, and they just gave me that camera, the new camera. Just gave it to me. All right, so we want to look at x squared, the graph of x squared. I went to y equals, it's going to focus here in a second. It's going to focus. It better focus. There we go. We got to focus in there now. Okay, so we're going to do y equals x squared. There's a graph, and it says what happens if you look at the first one, horizontal shift. If I put in my function, I'm going to put the y equals x squared. There's my x squared. I'm going to put it in parentheses. I just want to show you that I'm putting y equals x squared in parentheses. If I put on the inside of the function a -5, if on the inside of the function I put a -5, watch what happens when I hit graph. There's the original x squared, and a -5 moves it kind of like in the opposite direction. It does a horizontal shift. If you look to the left, it says f minus. -5 moves it to the right. So a horizontal shift, a negative moves it to the right. If I change that to a +5, it should move 5 spaces to the left. So there's the original, and there's the +5 on the inside of the function. Do you see that +5 on the inside of the function? It moves that original to the left. And hopefully everybody has these down. This is from algebra once again. So there's the x squared. So if you look down, vertical shift now, it's a -5, but the -5 is on the outside of the function. That -c is on the outside. So I'm going to do a -5 on the outside, and a -5 moves the graph. There's the original. A -5 moves the graph down 5 spots. And if I change that to a +5 on the outside, there's the original. A +5 moves the graph up. So a plus on the outside moves it up, a minus moves it down. However, a minus on the inside, you'd think a minus would move it to the left, but it doesn't. A minus moves it to the right on the inside, and a plus on the inside moves it to the left. Let's do a minus. So now we're going to do a minus in front of the function. Let me get rid of this. And we're going to put a minus inside of the outside of the function. Wait, that's not right. Give me a second. I can do it here, hit insert, and minus. There we go. So there's a minus on the outside of the function. It's a reflection. There's the original, and it reflects it upon the y-axis. Not necessarily on the y-axis. It reflects it on its vertex. So a lot of people say on the x-axis, but it actually reflects it on the vertex. You can say reflects it on the x-axis. So the last one, we want to put a minus on the inside of the function. Delete this and put a minus on the inside of the function. There we go. See what happens? There's the original. There's the new one. It looks the same, but it's not. What happens is a minus on the inside moves the left side over to the right and the right side over to the left. It reflects it on the y-axis. So this part goes over here, this part over here. A minus on the outside just flips it down to here, but a minus on the inside flips it with respect to the y-axis. On the what do you call that? The axis of symmetry. So it'll flip this side and then it'll flip that side. So that's transformations. We do a lot of transformations in calculus. So hopefully everybody's up to speed on these transformations. Well, up to speed on all of our algebra. Okay. Did I just hit stop sharing? All right, next, here we go. Anybody know what that symbol is between the F and G? What do you call that?
Is it
What?
of?
Yeah, but what does that mean, of? F of G. It is pronounced F of G. That's how you say it. But what is that symbol? It has a name. You know, so if I say, what kind of problem is this? You don't say it's an of problem. What kind of problem is this? What is it called? Starts with a C.
Composite.
Composite, composition. It's a composite function. It's a composite function. And the way we do composite functions, you always do what's on the right-hand side first. Do this if there's any math involved, and then you plug your answer into the x value of the left function. So first we're going to do g of x in this first problem here. G of x is cosine x. So g of x is cosine x. You're going to plug that into the f function. Do you see that? This becomes, it goes into here. 2x minus 3. This cosine, now since g of x, whatever g of x equals, it equals cosine x. That goes into the x values of the f function. There's the f function. This is the f function. We're putting that into here. So in other words, we're putting cosine x into here. And that's the composite of f and g. That's the answer. I mean, you can 2 cosine x minus 3. That's the answer. That's it. Now the other one, first we're going to do this one. And f of x just equals, we're going to put, let me give myself a little extra room. Where our final function is going to be the g function. And the g function is the cosine of x. First, we're going to take and find the f function. The f function is 2x minus 3. Let me do this in red, or let me clear out this other stuff. So first we're going to find the f function. There's the f function. We're finding this one first. And we're putting it inside of the g function. We're putting this f function into the g function. And then 2x minus 3 goes in here. In other words, 2x minus 3 goes in here. And there's no math involved. The answer is just 2x minus 3. And that's my answer. The composite of g of f equals this. You take the right function and you put it into the x value of the left function, composites. So once again, I'm hoping all of this is just a quick refresher of algebra. Because we did all of this in algebra, and you're required to know this. This is really, really basic stuff for us. Testing even and odd functions. What this says is for an even function, if you put a negative in place of the x, if you put a negative x in place of the x, and you get the original function, then it's an even function. And I'm going to show you an example of an even function. So this is even. The one we just did, f of x equals x squared. Do you see? If I put a negative x in there, that's what it's saying. If you put a negative x in the original function, put the negative x in there. Does anybody know what negative x squared is?
X squared.
It's just x squared. Do you see how we get the same answer? If you put a negative into the original function and you get the original function, then it's an even function. So f of x equals x squared is an even function. Odd functions. If you put a negative inside of the function and you get a negative outside of the function, your function turns negative, then we call it an odd function. And here's an example of an odd function, x to the third. F of x equals x to the third. If I put a negative into that function, negative x to the third, when you do a negative power to the third, you still get a negative answer. And if you look, if I put a negative into the function like I did, and I end up with a negative in front of the original function, there's the original, the function is odd. So x to the third is an odd function. All right, that wasn't too bad, and they probably hopefully those are probably the next slides. We'll see. Or if it lets me go, it's giving me a hard time on going to the next slides. I wonder. Oh, I gotta get out of the writing part, I think. There we go. And test for odd or even. So let's just test for odd or even here. So testing for even function, put a negative into the original. Well, we're just putting, both of those, you're putting a negative in the original. Put a negative in the original. Everywhere there's an x, put a negative x. Negative x to the third is negative x to the third. Negative, negative, this changes to a positive. So can you tell me, is this an odd or an even function? When I put a negative in, did I get the original or did I get a negative in front of the original? In the chat box, type in odd or even. Is there even a chat box available? Type in odd or even. Everybody's copying everybody, it looks like. You guys are copycats. I really can't believe everybody copied everybody else. By the way, you're all wrong. It's not even either. It's neither. First of all, does this, if it looks like the original, does this one look like that one? No, it does not look like that one. So it's not even. Now, if it was odd, you could put a negative in front of the function. You had to distribute that negative. Oh, wait. You guys are right. I'm sorry. For some reason, wait, no. Oh, it is odd. I thought everybody was wrong. Hey, your instructor is going to be wrong a lot. So if you put a negative in front of the function, oh, wait, no. Oh, yeah, this is the odd function. If you put a negative in front of the function, that turns negative, that turns positive. Yes. And so this is the distributed value. This is the same when you put a negative in front. In other words, we put a negative inside. So this function is odd. Okay, you guys are right. God, for some reason, I thought one of the signs were going to change. I thought one of them was a square. Okay, so yes, that function is odd because it's the same thing as writing a negative in front of all of this. It would be the same thing. And that's what an odd function is, taking the original function and putting a negative in front of the whole thing as a thing here. Over here, 1 plus the cosine of x. If I put a negative in there, actually, there you go. Hey, that's good. I'm testing you. By the way, I thought I said you were all wrong, but then I mentioned you guys are kind of right. Look at this. If you put a negative inside of a cosine, what happens? Are those equal? You might want to go to your trig sheet and take a look at that. I think trig sheets talk about that. I want you guys to do that. I want you to do this on your, I want you to do this. So everybody write this one down and do this for Monday. I have a feeling on Monday, I'm going to do a quiz on this one. I want to know, first you put a negative inside of the x and tell me I want to know if it's even, if it's odd, and if it's not even and if it's not odd, then it's neither. And I want you to tell me why. And I'm going to leave it as that.
How do you know whether the function is neither of even or odd?
When, by the way, if we ended up with, see here, if you look at this one, if we ended up with x3 plus x, do you see it's not the same, so it's not even. And this is the odd one, a negative x3 plus x. It's not the same as an odd function, so we call it neither. So if it's neither if it's not even and it's not odd.
So if we get a new formula or equation, get neither.
Yes. I do want, I might as well do this. If you look at, let's print, I need you to print out this trig sheet. On this trig sheet, you guys can't see it. I'm going to try to just put it up to this camera so I don't want to mess with that other camera. I want you guys look at this trig sheet. I want you guys actually look at, and find this out. Right here, it talks about trig identities that are even and odd. And it, where's my fingers at? How come I can't see it there? It's hard to see. So I want you guys print out those trig forms that I have there. It actually shows you this, that cosine of negative theta or negative x is the same thing as cosine of x. In other words, the cosine of negative pi over 2 is the same thing as the cosine of pi over 2. What they're saying is they're the same. So cosine is an even function. So the 1 doesn't change anything. So I guess you don't have to turn it in on Monday. I wanted to know why it was an even function, because this and cosine x are the same. That's a trig function. That's a trig identity. That's a trig identity that we had to know from pre-cal, that if you put a negative inside of the parentheses for cosine, it's the same thing as having a positive. You get the same answer for either one. And if you look at the unit circle for that, it'll show that out, show that. And we're actually going to be using the unit circle a lot. That's one of the things I have you print out here also. All right, and that was the end of that slide. And I'm going to hit stop recording.